And we're back and better than ever again, and we're still in 7.1 dealing with ions and ion formation. In the last podcast, we were talking about the difference between valence and core electrons. The valence electrons are those in the highest occupied energy level. The core or kernel electrons are in the lower energy levels. We were also observing the octet rule, where metals will tend to lose electrons to achieve a noble gas configurations, which is actually 8 electrons in the highest occupied energy level, while nonmetals will tend to gain the electrons to achieve the same thing. And so if you scroll down, or flip the page in your case, let's show you how this works. In the terms of formation of cations, which is what metals will do. If you look at sodium, sodium is a 1s2, 2s2, 2p6, 3s1 configuration. Neon, on the other hand, is simply a 1s2, 2s2, 2p6. And so what sodium is going to do is it's going to lose its one valence electron. If it loses that valence electron, there are no electrons in the third energy level, so that means that the second energy level becomes the highest occupied energy level. And if you notice, these two configurations are identical to one another. So sodium has now achieved a 1s2, 2s2, 2p6 electron configuration, which matches that of neon, which is very, very stable. Also, in terms of satisfying the octet, the second energy level now contains 8 total electrons to match that of neon. That is the octet rule. Now you might be saying, well, wait a minute, there's 2 in the 2s and there's 6 in the 2p's. Isn't there just 6 electrons in the highest occupied energy level? No. The second energy level together is an energy level, the 2s and the 2p. The s and the p are simply sublevels of that second energy level. So you do have to count them together. So in fact, sodium has achieved what is called the octet. Now if you scroll, now by the way, all metals will do this. They will lose their electrons to achieve a configuration that is either identical to or very similar to the previous noble gas. Now nonmetals, on the other hand, are going to form anions by gaining electrons. Notice chlorine. Chlorine is a 1s2, 2s2, 2p6, 3s2, 3p5. While argon, on the other hand, is a 1s2, 2s2, 2p6, 3s2, 3p6, meaning that it has a total of 8 electrons in that highest occupied energy level, the third energy level. Argon already has the octet, which makes it very, very stable. Now, in the case of chlorine, if chlorine simply takes on 1 extra electron, it will fill the third energy level and it will have a configuration identical to argon. And so that makes it very, very stable. So nonmetals are going to do that. They're going to gain electrons, whatever electrons are necessary, to form or to achieve a noble gas configuration. Now notice when you do add a negative charge, it does take on a negative charge. On the other hand, as you lose electrons, say sodium, sodium went from having 11 electrons to 10 electrons. If you write down the charges, sodium has 11 protons. It normally has 11 electrons, so it's neutral. However, when it loses 1 electron, it now only has 10. So it has 1 more positive than negative, so that means it has a 1 more positive overall charge, which is why it has a +1 charge. On the other hand, going back to chlorine, chlorine does the opposite. Chlorine, which has 17 protons and 17 electrons normally, when it gains that electron, it now has 1 more negative than positive, which gives it an overall -1 charge. Alright? This is basically what happens when ions form. They're going to either lose or gain electrons to achieve a noble gas configuration, which is why anything in column 1, the alkali metals, have one more electron than the previous noble gas. So if they all lose one electron to achieve that noble gas, they're all going to form plus ones. The alkali metals, on the other hand, will form plus twos. Why? Because they're going to all lose two electrons to achieve the noble gas configuration. Now, we've mentioned before, we don't worry about the transition metals, at least right now, because they do a lot of different things. However, if you jump over to, say, aluminum, aluminum has 3 more electrons than neon. If it loses those 3 electrons, it will be like neon, and it will form a plus 3 charge, as does the other elements in that particular column. Now, going to the nonmetals. The halogens are 1 electron shy of the noble gases. Fluorine is 1 shy of neon. Chlorine is 1 shy of argon. Beryllium is 1 shy of krypton, and so on and so forth. So if any of the halogens take on 1 electron, they will become like the noble gases. So they do that. They form minus ones. The oxygen group needs 2 electrons to form noble gas configurations, and the nitrogen group needs 3. And so that is why we see the charges forming in the various groups. They are all either losing or gaining electrons to achieve this noble gas configuration, which is incredibly stable. And stability is the name of the game. All right, if you have questions on that, see me. Otherwise, that concludes 7.1.